Now let's go over leetcode question number 1165, single row keyboard. Now the question says there is a special keyboard with all keys in a single row. So all the keys are in a single row, not like our regular keyboard. Given a string keyboard length 26, so we're going to be given a string that's going to be our keyboard. It has a length of 26, indicating the layout of the keyboard. So whatever string that we get, that's the layout of the keyboard. So index from 0 to 25. Initially, your finger is at index 1. So our finger is going to be at the first character. And to type a character, you have to move your finger to index of the desired character. Okay, that makes sense. So if A was here, our C was here, and our Z was here, I would have to traverse from here to all the way here to get C. The time taken to move your finger from index I to index J is I minus J. So let's say that this was index 0 and this was, I don't know, index 10. So time it takes is 10 minus 1, which is 10. You want to type a string word, write a function to calculate how much time it takes to type it with one finger. So you're just typing with one finger. So let's say that our character is ACZ. So at first, I'm going to start index 0. And I'm going to go all the way through C, which is at index 10. So it took 10 seconds. Now I need to go from C to Z. And let's say our Z is at index 5. And from C to 5, that's a difference of 5, right? So that's going to be another 5 seconds. So in total, it took me 15 seconds. So that's the idea of the problem. Now let's look at an example. So we are given our keyboard and this is our word and our output is 4. So how did we get that? Well, our first character is C and C is at index 0, 1, 2 and we always start at index 0. So that's 2 minus 0, which is 2 over here, and then it's B. Well, we were at character C, right? So C has an index of 2 and B has an index of 1. So what's the difference? Well, like 1 second. So that's why we're here. And next is A. Well, we're currently at index 1, which is at character B. And now we are going to character A, which is now at index 0. So that's going to be another 1. And you can see that we have 1 over here. So the total time it took for us to type CBA is going to be 4. And it's going to be the same logic for this one. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's go over our first solution for our question, and our time complexity is going to be O of n and space is going to be O of 1. Now if you notice, I have something like O of 26 times O of n, and if you know time complexity, this simplifies to O of n because we want to drop the constants, right? And we will go over why our time complexity is like this. So before that, let's finish coding our solution. What I want to do is I want to create a loop to iterate through my word, and also I want to create a loop within that loop, so a next loop to iterate through all my string, and I want to find the match of my current string with the keyboard. And if I do have a match, I want to get the absolute distance and add it to a total distance that I'm going to save to a variable. So let's try implementing that. First, I want to create a variable named distance, and this is going to store the total distance, and I will initialize it to 0. And then I want to create another variable called previous index, and this will be 0. And previous index will point to wherever my last key left off of on the keyboard. So for example, for the first one, the first character is C, right? So I go from 0 to C, and then if I go to B next, my previous index is going to be this index where C is at, so that's 2, right? So that I can get the distance between C and B. Now let's create a loop to iterate through our word. So that's going to be I is equal to 0, I is going to be less than word.length, and we increment by 1 each time. Now you want to be able to iterate through our keyboard, so let's do that. So for let j is equal to 0 and j is going to be less than 26. And we increment j by 1 each time. Well, why is it 26? Why isn't it keyboard.length? Well, the reason is because we're always going to have only 26 characters in the alphabet, and the alphabet isn't going to change anytime soon. And if you look on the question, it said that one of the conditions were that the length of keyboard is always going to be 26, and that's because we have 26 alphabets, right? So that's why I just put it 26. And now is our if case. So if our current word, so word at index I, if this is equal to our current character on the string, so that's going to be keyboard at index j. If that's true, what do you want to do? Well, we want to add the absolute distance to our total distance, right? Which we call distance over here. So let's do that. So distance plus equals, and how do we get the absolute distance? Well, that's going to be math.absolute. And what values do we have to subtract? Well, it's going to be previous index minus our current spot, which is represented by our index j. So that's going to be previous minus j, and we spelled previous index wrong over here, so we should have a v. Okay, that looks good. And now after that, we need to overwrite our previous index with where we are at. So in the first iteration, previous index is at 0 because remember the question said we want to start at the first character all the way to the left, and then we go to C, which is at index 2, and we want to save this index to our previous index so that when we look for B, we want to move from C to B. So let's do that over here. Previous index is equal to RJ, and that's it. And finally, we want to return our distance. And as you can see, we have our result. So that's it. Let's just go over our code one more time. We have our distance to save our total distance, previous index to point to the previous index of where we left off on the keyboard. Now we are iterating through all the characters in our word, so CBA, and next we are iterating through all the characters in our keyboard. And remember that alphabet is 26 letters, and that's not going to change anytime soon. So that's why I just put 26. And then next we check, well, is our current character, for our case right now is C, is this equal to the current character at index J? So our current character is gonna keep changing. So first it's going to be A, is it B, and then it's going to be C, and then it's going to be C. Well, C is equal to C. So we go into this block and then do distance plus equals the absolute distance between the previous index and the current index. Well, it happened to be the case that our previous index was at 0 because again, the problem wants us to start at the beginning, and then we got to C and we subtract 0 minus 2, and that is going to give us 2, right? So we add 2 to our distance, and we want to save our previous index because when we want to get our next character, which is B, we want to move from C to B. We're not starting again from index 0. So we want to go C to B and then later B to A. So we want to save our previous index, and that's what we did. And index J is the one that we want because this is the one that is iterating through our keyboard. And finally, we return our distance. Now let's go back to our time complexity, and remember that we said that this is going to be O of n. And you might think, well, if you have a nested loop, isn't that a O of n squared operation? Well, that's the case if our keyboard length would change, but since this is a constant, it's never gonna change. So what we do is we have O of 26 times O of n, which simplifies to O of n because one of the rules for time complexity is that we have to drop our constants. So technically, our time complexity is O of n. Now let's implement our second solution. Our second solution is pretty much going to look the same as our first solution. It's just that we're going to use an index of to find the character that we want. So that's really the only difference. So if you can, try to implement it yourself because other than that one line, it's going to be exactly the same thing. Now, let's create two variables like before, our distance and our previous index, and set both to 0. Now, we want to iterate through our words. So that's going to be I is equal to 0, increment by 1 each time. And then next, you want to get our index of the current character. So in order for us to do that, let's use index of. So I'm going to save that index to a variable j, and let's do keyboard.index of our current character, which is word at index I. Now that we have our index, actually let's just console log our index. As you can see, we have our indexes, right? So let's comment this out. We have 2 for C, 1 for B, and 0 for A. So this is our index, whereas before we had a nested loop, just a regular for loop to get our index, and we were checking if the current character and current character for our keyboard was equal to each other, we returned the absolute difference, right? So here we're just finding our index from our keyboard using index of. Now what we need to do is we need to add the distance to our distance variable. So that's going to be distance plus equals, same as before, math.absolute value. We pass in our previous index and we subtract our j. And now we want to set our previous index to our current location on the keyboard. And finally, we return our result. So that's going to be return distance. And as you can see, we have 4 and 73 for our second one. Now let's try to implement another solution. This one is obviously going to have a space complexity of, again, O of n, and O of n is for the word, and O of 26 is for the keyboard because alphabet is 26 letters. And this is actually going to have a worse space complexity, but I just wanted to do this one also just for fun. And for this one, we are going to use new map. What I'm going to do is I'm going to get all the elements from my keyboard and I'm going to put all the letters as keys, and I'm going to store indexes for each element as values. And from that, I'm going to get the index from the map and do our same old calculations to get our total distance. Now, first thing I want to do is I want to create a map. It's going to be new map. Now let's iterate through our keyboard and put all the elements to our map. Now let's use a for loop for let I is equal to 0, I is going to be less than 26, and we increment by 1 each time. And in order for us to add elements to our new map, we need to use the set method. So that's going to be map.set. First argument is going to be our key, and our key is going to be keyboard at index I. So that's our alphabet. And next is going to be our value, and we want our values to be the index, right? And index is represented by variable I. So we add our I, and that's it for our map. And let's console log our map to see what we get. Comment this one out, and you can see that we have our map of our keyboard. So A is at index 0, B at 1, C at 2, Z at 25. So let's get rid of this one. And let's create our variables for our distance. Set this equal to 0, and we need our previous index and also set this equal to 0. Now let's iterate through our words. So let's use for loop again. Now we have our for loop. So for each character, we have to look it into our map and get the index. So how do we get the value from our map? We use get method. So map.get, and we want to get our current character, which is represented by word.index I. So if I were to just save this as a variable, const j is equal to map, and let's console log this, and you can see that we get our indexes for each character, right? So we passed in our key and we got our values, which represented again the index. Now we need to add that to our distance, so that's going to be distance plus equals, and we want absolute value because we need to subtract our previous index minus j. And let's respell our previous index, capitalize R I, and capitalize I here too. Okay, that looks good. And finally, we need to save our previous index so that we can use it later, and that's going to be equal to j. And now we need to return our result, which is distance. And as you can see, we have our result. On comment this, we have 73, and that's it for our solution. Now let's go over this one more time. This also has a O of n for time because, again, the length of the keyboard is going to be 26, which is constant, and we want to drop constants when we calculate time complexity, and the number of alphabets is never going to change. So it's good to say that I think it's O of n, but otherwise it will be O of n plus m, whereas this is the O of n operation, and this would be O of m if our keyboard were to change again. Now what we did was we created a dictionary or map of our key value pairs, right? And our key represented the alphabets and our values represented the index. So when we add elements, we use map.set and we add our key and our index as I. After that, we iterate through all the characters in our word and we get the index of each word. And remember that index was represented by the values in our map object. So we get our current key, pass it into our get method, and our get method is going to return our value, which is index. And we get the absolute value of the distance from the previous minus our current position. And we want to save our current position so that we can use it later. And we save that to our previous index. And finally, we return our result. If you guys find this helpful, make sure you guys like and subscribe. Thanks.